There are also three basic methods of charge transfer that I want you to know. I'll go ahead and spell them out now, and then we'll go through them one by one. They are conduction, which might sound familiar to you when we talked about rates or methods of heat transfer, conduction, induction, and charging by friction. The third one, you probably know what that's about. With each of these, here's what you need to focus on as I go through them and teach them. You need to first of all understand the method itself, how it happens, and you need to know the result of that method of charge transfer. And I'll emphasize both of those as we go along. So conduction, induction, and charging by friction. First of all, conduction. Move me out of the way. Conduction, as you might remember from heat transfer, conduction was heat transfer by direct contact or by touch. And it's the same here, except we're not transferring heat. We're transferring charge by touching two objects together. In that case, one of them needs to be charged. If you have two neutral objects and they touch together, nothing's going to happen there. No charge is going to transfer. But one of them can be charged. Actually, now that I say that, they have to have different charges. If they have the same amount of charge, nothing is going to be transferred, which was the same as temperature. Two objects that have the same temperature, touch them together, no heat gets transferred. Same here. One of them can be charged, both of them can be charged. They have to have a different charge. In other words, one of them could even be neutral and the other could be charged. Lots of different possibilities. So the method is that we touch two objects together that have different charges. The result of conduction is that both objects end up having the exact same charge. They have, number one, the same amount of charge, and they will end up with the same kind too, either positive or negative. Again, this is really similar to conduction like we talked about with heat transfer. That heat got transferred until thermal equilibrium happened, until those two objects were at the same temperature. This is no different. This transfer is going to happen until the objects have the same charge. They'll both end up positive or they'll both end up negative. So here's a diagram illustrating how this happens. We have a negatively charged rod on the left, and we're assuming that this object here is neutral. Again, neutral doesn't mean that there are no charges. It means equal amounts of protons and electrons. Second picture, we touch the negatively charged object to the positively charged or to the neutral object. That simply gives the electrons an ability to flow. Now they don't jump as this picture shows. They will simply move through the area of contact into that other object until their two charges are equal. Now we take them away. This one is still negatively charged, but it's lost some of that negatively charge. This one ends up with a negative charge too, and the three negative marks on each indicates that they both have the same charge. Now, this is a really important point. I highly recommend that you write this down. In conduction, you need to know what direction the charge will flow. And electrons will always move to the less negative object until their charges are equal. This one statement is very, very important. Pause the video right now if you need to and write this down. Electrons always move from the less negative or more positive move to that less negative object until their charges are equal. Now, there's a reason I say less negative, and I'll show you that by looking at these examples here. So let's imagine that this object has a -5 charge. That -5 is simply going to indicate right now that we've got more protons than electrons, specifically 5 more in this case. Another object has a +5 charge, which isn't really a real unit of charge. It's just indicating that this one has more protons than electrons. So this one has an excess of electrons. This one has a deficiency of electrons. And if we touch the two together, 5 electrons will flow from the one on the left to the one on the right. The one on the left loses 5 electrons, which makes it end up with 10 electrons and 10 protons, and its final charge is 0. But the one on the right has now gained 5 electrons. 5 plus 5 is 10. It ends up with 10 electrons and 10 protons. Both end up neutral. So notice we started out at -5, +5, and we end up at a charge that's right in the middle of the two. Again, very similar to heat transfer and temperature. We end up at neutral here. Now, you don't always end up at neutral. They just happen to be in this case. So for instance, let's take this one. We have a -6 on the left because there are 6 more protons than electrons. We have a neutral object on the right because there's an equal number. When we touch these together, you predict where are the electrons going to go. Hopefully you predicted that they'll move to the neutral object. Now, I didn't say they're going to move to the neutral object, but in this case, the neutral of these two is the less negative object. Obviously, 0 is less negative than -6. So we touch the two, we get electron movement, but 3 of them move over. 3 of them move over because it's going to happen until they have the same charge, and you might have guessed that -3 is in between -6 and 0. The one on the left-hand side is going to lose those 3, and we end up with a -3 charge because it ends up with 13 electrons. This one gains 3 electrons, ends up with the same charge, 13 and 10. Notice we end up the same. Here's another one. -10 on the left, -6 on the right. Pause the video, predict what's going to happen and what the final charges are. All right, so we push them together. 2 electrons go over. The one on the left ends up at -8 because it has 18 protons now, having lost 2. The one on the right will gain those 2 and end up the same thing, -8. One more. This one's a little bit different, a little bit tougher. Pause the video, predict what's going to happen there. So this one's the most interesting. Electrons move toward the less negative object. But when we touch these, 2 electrons go toward the +6. And you're going, okay, how does that work? Well, remember, less negative also means more positive. This one has a greater deficiency of electrons. So the electrons want to go over here. See, here's what's going on here. When we talked about thermodynamics, we talked about the second law of thermodynamics, which says that energy spreads out. Well, this is no different. Electrons are electrical energy, and they want to spread out. They don't want to be concentrated. That's all that's going on with conduction. They're trying to spread out into a place where the energy is less concentrated. So if 2 electrons go over here to the -6, we want to end up at the same charge, and what is in between +6 and +2 is 4. So this one gains those 2 electrons, so we end up with 6 and 10. This one loses 2 electrons, so we end up with, again, 6 and 10, leaving us at +4, +4. So this is conduction. Charge transfer by touch, end up with the same charge.